Good morning and welcome everyone. Thank you for joining us for the Kootenai Conservation Program's Winter Webinar Series. This year, our series focuses on the theme of From Alpine to Valley Bottom, Conserving Essential Habitats in the Kootenays. My name is Marcy Marr and I'm KCP's Stewardship Coordinator and will be the host for today's webinar. Nicole Trigg, KCP's Communications Coordinator, is also on board to ensure that our technology runs smoothly this morning. Given the rich heritage of stewardship in the Kootenai region, I'd like to acknowledge that KCP's work occurs in the traditional territories of the Ktunaxa, Shuswap, Sinixt, and Syilx peoples, who've lived here and stewarded the land and water for many generations. While some people are still joining us, I'd like to talk a bit about the Kootenai Conservation Program, known as KCP. We're a broad partnership founded in 2002 and currently comprised of more than 80 land and water conservation and stewardship groups, government agencies, resource industries, and agricultural producers working throughout the East and West Kootenays in southeastern BC. KCP's mandate is to coordinate and facilitate conservation efforts on private land and to generate the support and resources needed to maintain this effort. We achieve this through increasing the effectiveness, collaboration, and coordination of private land securement and stewardship activities, building financial and technical capacity of partner organizations, and serving as a network to achieve efficiencies, synergies, and ultimately greater effectiveness. We're always interested to know who's joined us today, so please respond to these two questions in the chat box, which you'll find in the toolbar at the bottom of your screen. So please let us know where you're based and your affiliation, and I'll give you a moment to do that. Today is the third webinar of our four-part series. We have had excellent and interesting group of speakers thus far. And so if you have missed our first two webinars, Drones and Dens, and BC's Old Growth Forest, you can find links to the recordings at KCP's website, kootenaiconservation.ca. Before we get to our featured presenter, I'd like to tell you about our upcoming webinar. On February 25th, we will wrap up our webinar series with Ryan Durand of Ecological Consultants, who will describe the Columbia Valley Wetland Mapping Project, combining digital technologies and wetland ecology. And now I'd like to quickly go through some information about this webinar. It'll be approximately 40 minutes with up to 15 minutes for questions at the end. As an audience member, you are on mute for the presentation. If you're not familiar with Zoom, please locate your toolbar and look for the chat and also the question and answer boxes. Those we'll be using throughout the webinar. If you have questions for Brian about the presentation, please put your questions in the Q&A option, and then I'll be sure to find them at the end of the webinar, and that's when we're going to answer them. And if you have any technical issues or need to communicate with Nicole or I, please use the chat option at the bottom of your toolbar, and Nicole will be monitoring that and do her best to help you. This webinar will be recorded and will be made available on our website. And also the link will be in a follow-up email that we send you, along with the presenter's contact information and a short post-webinar survey. That we hope you'll please fill out, because that helps us plan for the next KCP Winter Webinar Series. And we're always very grateful to our funders and supporters of the KCP, without whom we couldn't do these types of programs. So big thanks to them. So now I would like to introduce today's speaker, Brian Churchill, who these days refers to himself as a nominally retired biologist. He spent his youth in Cranbrook and has attained a Bachelor's of Science from the University of Victoria and a Master's of Science in Forest Wildlife from the University of British Columbia. Brian has worked as a biologist and regional wildlife and habitat section head with the Ministry of Environment and subsequently as a consultant. He has worked on conservation biology and wildlife management projects involving swans, mountain goats, mountain sheep, caribou, moose, elk, deer, grizzly bear, and biodiversity values. He's most proud of his role leading a Ministry of Environment team that delivered land and resource management plans for 3 Peace Forest districts. He also has served as a director of the Yellowstone to Yukon Conservation Initiative and president of the College of Applied Biology. In 2011, Brian and Rita returned to the Kootenays, making Creston their home, where he's recently the president of Wildsight Creston Valley Branch and director with the Creston Community Forest. In today's presentation, Looking for the Big Picture, the Creston Valley Green Map and Habitat Connectivity, Brian will review the development and structure of the GIS-based green map of the Creston Valley, identify conservation values, threats, and possible ecological corridors, and discuss how Creston's green map can assist decision makers and engage the public in greater environmental awareness. So thank you, Brian, for being a part of KCP's webinar series, and I'll turn it over to you.
There we go. Good morning, everyone, and welcome to my webinar here. This is talking about the Creston Valley and looking for the big picture, and I'll talk to you a little bit about that in a while as we talk about why we wanted to do this. But first of all, I'm going to learn how to run this thing properly. We'd like to acknowledge that the Creston Valley is the traditional territory of the Ktunaxa Nation and home to the Ecological people. They have stewarded the valley for successive generations before European colonization. We acknowledge, with respect, that we could learn much from Indigenous perspectives of caring for ecosystems and people, and then we must learn how to cultivate meaningful relationship with the people in the land. What is a green map? Green map, if you'll see, there's a link here, a web address. It's an organization. It's a locally made map highlighting sustainable resources of a particular geographic area. It could vary widely in terms of goals, content, and design. It's comprehensive inventories to support decision making, and it gives an interesting perspective for people. Wildsight Creston Valley is a local organization that is formed to engage and inspire the local community in the protection and management of ecosystems, and robust objective mapping products are helpful to guide this work. Our project goal was to complete an analysis and mapping exercise to digitally analyze and visually present the habitat characteristics in the valley, the habitat importance for biodiversity, to identify gaps in existing protected areas, show generalized priorities for future conservation efforts, and additionally analyze some other stuff. The study area boundary, as you can see, is from the American border up along the ridge lines of the mountains, the Purcells on the right and the Syilx on the left, and right along the end of Kootenay Lake. And this was an arbitrary decision that we felt was important to the people in Creston Valley Wildsight. This is a little better perspective of it, and you can see we've got the mountains identified, the Syilx and the Purcells, Kootenay Lake, and the ridge lines, the Creston Valley Wildlife Management Area, which many of you will be familiar with, is here along the valley bottom in the middle, including Duck Lake. And I've highlighted here that the reserves of the lower Kootenay Band. A special note here is that this crosshatched area that you can see in light gray here is an area that is part of the diking project that has been managing water in the Creston Valley since the early 1900s. And most of this area is a highly developed for agriculture and very dramatically altered. Our summary of this is we're going to take data from 28 geospatial data sets. We're going to do a suitability analysis to identify 6 themes. We're going to take these themes and put them into two areas, and then we're going to come out of it with a green map. To find the appropriateness of given areas for special uses, we do a suitability analysis, and there's a premise here that landscapes have characteristics that are suitable for an activity. We do a multi-factor analysis, and the results are often displayed on a map from high to low suitability. Now, our 28 different databases are listed here under their themes. So in rarity, we have biogeoclimatic BEC, we have PEM, and we have VRI, vegetation resources. For wildlife, we used ungulate winter ranges, occurrences of blue and listed animal species, red listed animal species, and a special one, the cost to travel to water sources. For a conservation area gap analysis, again, we used BEC, but we looked at underrepresentation in the provincial network, and we looked at underrepresentation in the local network of protected areas. And underrepresentation of leading tree species type, and particularly for cottonwoods. For human footprint, we identified road density, building density, community watersheds, water license, private property. And some risk factors we tried to throw into this one to see how it worked. Wildfire treatment priorities, erosion and flooding risks, terrain instability, and surface material modifying in the VRI. We took these 6 themes. We did another suitability analysis on between 4 of the 6 themes, and rarity, wildlife, conservation, and forest and floral, to make a natural values aggregate. And we combine human footprint and risk factors to make a social values aggregate. And the map output of this shows natural value hotspots from the natural values analysis, and limiting social factors, where it says that social factors are limiting natural values. And that goes together to create a green map. So now I want to go through it in a bit of detail. So I'm going to show you, starting with theme number 1, how we got representation in conservation areas. We'll go through that in a little bit of detail, and then I'll just show you the aggregate ones for the other themes. In general, this is a hypothetical one. You have 3 data layers, and you take those 3 data layers, and you create a composite of them. And part of this is done by taking the values of each of these data layers, applying with a cluster analysis by the pixel to get a numerical value, and this numerical value then comes in here, and it's categorized by, and this creates a thing. So in conservation data analysis, first off, we looked at what's underrepresented by BEC analysis provincially, and you can see that the BEC classification showing in here. And then we looked at what is below representation in the local. And as you can see, there's quite a significant difference between local and provincial levels of representation in these areas. So it depends on your perspective. If you're looking at a provincial gap analysis, it's quite different than gap analysis for local conservation areas. We looked at leading tree species representation, and again, an over and under representation, in this case, explained here by color shadings, the red being highly underrepresented, and the yellow being moderately underrepresented, and it goes down to green for those that are represented, and we don't show that, of course, because we're trying to declutter the map. Please notice in all these maps, we've got the Creston Valley Wildlife Management Area outlined here, and we got the conservation outlined there. So our suitability analysis outcome is the composite of these three maps done through that process of analysis of numerical representation of each of those maps. So then we look at what's not represented, and this becomes our theme map for conservation gap analysis, and it tells us that the valley walls are not particularly well represented in this area. Bear in mind in all this that we do not have data for this big strip coming down the middle of the valley, this one here. So and we come up with a habitat rarity one done by a similar analysis on blue and red species and leading, and you can see these are the habitats that are quite rare in the valley, with the darker colors being very rare and the lighter colors being less rare. We looked at wildlife habitat values. We looked at ungulate winter range. We looked at what we had for red and blue listed species. We add them all together, and we've come up with a theme map for wildlife values. And you can see that the valley bottoms have a pretty strong representation, especially along the river here, and the caribou areas show up, of course. Forest and floral attributes, I'll come back to this later, but what areas from a plain forest and floral representation look to be high values, and you can see this is Arrow Creek over here with this big red part and up into the caribou. Whoops, we zipped on there for me. If we look at human footprint, we reversed it here with the dark colors being very strongly supports conservation in the fact that it's not impacted by the human footprint, and this stuff with no color at all has got a strong human footprint in it. So, and we had to have a look and see what kind of things would be subject to natural processes and that in terms of protected areas and that. So we've got some wildfire risks, we've got some flooding risks, we've got some geotechnical risks that show up. This one's especially quite interesting because this is the floodplain of the lower Goat River here coming down into the valley. So then the natural valley analysis takes these four themes and aggregates it into a natural features analysis. And it's done in black and white here because we're doing it with the pixel analysis. And then when we reanalyze it and put it in some categories, it comes out in the colored one. Similarly, using the human footprint and geotechnical and wildlife risks, we come up with an aggregated map for social factors that are basically limiting on conservation and protection. And this was the initial concept of the project, was to come up with some of these factors and see what the whole thing looked like so we could direct where we'd spend our time on conservation efforts. And you can see this thing's dipping through that analysis, and then we come up with a map. And the red outlines here the areas of top impact by human beings. Then finally, we come up with the actual green map by combining these two factors. So doing basically a conflict analysis to take and integrate natural features as high and social factors as limiting, put those two together, and again using this pixel analysis, this black and white, differing numbers for each pixel, and it also takes a little bit of a cluster analysis by analyzing the impact of the adjacent pixels as well, so you don't get really little spots. It gets a more general trend. And there we are. So out of that, we get a map of natural value hotspots. And this is actually the major product of the green map for the valley. And we look at what we've got in natural values in the valley, what we've got for conservation areas, and where we might focus looking at some of our activities. We put our limiting social factors on top of that, and we see we've got some quite strong conflicts up here along Duck Lake. We've got some conflicts here in West Creston, and as we go up the Goat River, the residential development there is impacting the values. And so a little summary: high natural value, Upper Arrow and Duck Creeks, Mount Thompson over here on the right, Corn Creek over here on the left. Riparian areas show all this high-ranking natural hotspots, and Creston and Windle, of course, are urban communities, so they have high constraints. Now we have the green map. We want to use it to ask some specific questions, and I'm going to go through Viewscape to show you how we did that. It's kind of an interesting thing, but it's a good illustration of the modeling to do, and then we'll get to the real nuts of the thing is the ecological connectivity modeling. So in Viewscape modeling, we take a viewscape, what can be seen from all the roads, in this case in the BC Road Atlas, what can you see and what can't be seen? And these black areas are what can't be seen from anywhere on the road network. So some kind of interesting segments here. And that's just for visibility. That's a human concept that doesn't have a lot to do with the ecology. This is similar. This is from recreation lines, which is the GIS term for mostly trails. And you can see there's it's a bit of a different map and a lot more areas that can't be seen. And you can think, if you're doing recreation planning, this might be an important map. We also have recreation points, places where people recreate. Here's Mount Thompson, way over here on the right, where people go a lot. So it's kind of important what you can see from that in terms of that recreational experience. So here you get an aggregated visibility. So the parts of the study area that are sort of quote as wilderness are the black areas and the darker areas. They're the areas that are less accessible and less visible to people. So it's how you could do a different kind of analysis for a different purpose using some of the data. Now, on our green map, well, in the end, we show up here with some of the high visibility, doing what are the most visible areas from the valley and what kind of management people might like to think about applying in some of those areas. If you're somebody in the Ministry of Forest Lands and all that stuff, you might pay some attention to that. Now I'm going to talk about the one that I think we got the most attention from our project is we did an extra study on ecological connectivity and resilience to climate change. So this comes out of a study that was done for North America from the States, that if you look at biologic systems, they did an analysis, and the URL is here, of important areas for connectivity of changing ecosystems due to climate change. So obviously the Rocky Mountain Trench, and more importantly, the interior wet belt here through Creston and Nelson and that show up. So we took this stuff and we looked at that data. We looked at local data being available. Here's Proctor and crew's work for grizzly bears. We looked at our green map, and we made them the important parts, the important natural parts of that as a proxy for ecological connectivity. And so we find out there's not much connectivity right here in the middle of Creston, where you can see my cursor, I hope. I don't know if you can see my cursor or not. But you can see where the connectivity is severely impacted, and this shows up in the black and white one a little bit better, and connectivity is really well connected in Arrow Creek and up here in Corn Creek, and interestingly enough, down here along the Kootenai River in a very important part of Lower Kootenai Band's lands and their culture. So there's a special analysis technique that we found out of it, and found some papers, and a great deal of credit goes here to Jan Troutlet for searching this out. And it uses a proxy of electrical connectivity for connecting natural areas. So if you think about there being two points here, two terminals, if you like, and then you run electric current through them, and the current goes according to the resistance, and it gives you a different pattern. So this GIS technique takes and applies this to the kind of points you want. So in the end, we used 27 different nodes in the valley, derived from the 702 maps that we've used, and come up with a connectivity modeling for the Creston Valley. And this is the cross the valley current, and you can see that there's some very strong connections here between the Goat River and the west side here down toward the boundary wildlife area in the States, and then we took and said, these are our natural value hotspots. They're really good ones that we've got left, not the ones that were there before, but the ones that are left. So we took and used all of them for a node, and then we did a current analysis of that, and that changed a little bit. It showed that these existing nodes change the way the current runs, and so we've got some connectivity here through Duck Lake and over into Arrow Creek. We've got very strong connectivity in the south part of Creston Valley Wildlife Management Area, and down here along the west side of the valley, so we also added data from whoops, sorry, I did that. We added data from the West Kootenai Climate Change Vulnerability and Resilience Project of Holt and Utzig, where they identified the forest, or vegetation types that are really vulnerable to climate change, and are going to change under the various models. And so we focused that down to these very important areas and put them in the analysis with their own weighting. So all these different inputs get some weighting. And I blew that again. Let me try again. And so we come up with an amalgamation of these various scenarios into a connectivity potential, where the connectivity is the best in the valley, according to this modeling. And that's what the final outcome map of that. And then we took and had a quick look at that and defined where the most likely corridors are. One of the things we looked at in this is distance from water, because distance from water has some impact on all of this. So we end up with this potential connectivity corridors in the Creston Valley, which we think is one of the big picture results of our project here. See if I can do this again. There we are. So this is what we've come up with. We've done Viewscape modeling to illustrate this and just open up people's minds, and you could do some kind of different things that might be relevant. But mostly what we looked at is the ecological connectivity. We identified that Creston Valley is at the crossroads of wildlife and climate connectivity, and that 5 corridor areas are really important. We want to do some more work if we can. We want some field evaluations. We want inputs from people that have some individual expertise and want to review some of this. We want to add some, whoops, I'm going to go back again. We want to go back or not go back. We want to go in and see what we can integrate using local and traditional ecological knowledge. We wanted a discussion with stakeholders, and I was really quite stoked to see that we've got quite a representation from the agriculture community and the people that signed up for this, and quite a representation of decision makers. And that was part of what this is about, although mostly it was about directing our own people to look at this. Sorry, I'm going to go back again. And we really wanted to identify some promising sites for conservation efforts for ourselves and others. And we looked at that you can upgrade this map, you can do some more analysis and improve on it. Special thanks to Jan Troutit here, who did the work as a co-op student from Selkirk College, and Ian Parfit, who supervises that program. They really did the work. The Wildsight Creston Valley Branch were the dreamers. We all have biology, forestry backgrounds, and land use planning backgrounds. As I pointed out, and I'll point out in a bit, reports available online, along with an interactive map presentation. And again, I want to thank Jan Troutit for going way above and beyond his work for his thesis and that by presenting this. So now I'm going to spend about 5 minutes, I hope, just going to our website and showing you that we're still hosting this interactive map. It's kind of fun if you're interested in this kind of stuff and want to stimulate your intellect to look at what you can do with it. So if you go to website Creston Valley, you come up with this screen, and you'll see it over on the left here. I've circled Creston Valley Home. If you look at it closely, you'll see that on one side it talks about the interactive green map, And then it'll also tell you that that's when you go to the green map part. It'll also tell you that the final report is here, and it's kind of an innocuous one, but if you want to download that report that was done 2 years ago, you can do that. If you click on the Creston Valley interactive map, you come up here, and it's important that you click on this interactive map one. We put it up bigger, and I'll take you to where it goes right now. It's going to take you to this scene, and when it comes up, we've already put on it the boundary, and we put on it the conservation areas. And then if you're interested, the conflicting land use is where the people are, is where this data and the agriculture is. And one of the things I didn't comment on there, that there's a lot of values down there still. That's the wrong one. We were missing data from Darkwoods up here as well. The end, let me count down here. 2, 4, 5. We end up with our areas of strong limitations by human occupation in this whole thing. But I'm going to leave that one on, and then I want to go down here to our forest and flora attributes. You have to click on this little stack thing to get this interactive menu on the sign, but you can do that. You can flip things on and off like logging. You can log in 1966 to 2016. But important, I think, you can see that we have very few reports of blue listed species. We got considerably more reports of red listed species, and a lot of them focus around the Creston Valley Wildlife Management Area. What I wanted to show you is and I'm just turning these off. Here's our white bark pine occurrences. And you can see they're just up there. That's where they are right now. But also you can get up the analysis where you might have white bark pine, and all of a sudden you can see it gives you a really different perspective on what's going on the land base and what some of the possibilities are. Because as we look forward to climate change, we have to look at possibilities also from what we got. For those of you of interest, there's our existing augments or old growth management areas. And then we have, let me see which one it is, number 3. Okay. We have one that tells us what stands are of interest to us in the valley, a lot to do with cottonwood management. So I encourage you to come. I encourage you to come to our website, have a look at this, see what it does for you, and oops, sorry. See if it's useful to you or not. And there we are. There's the thing that we think has become the most valuable and helped us focus our efforts in the valley. Thank you very much. And I think we're ready to go to Marcy here to deal with the questions.
Yes, thanks so much, Brian. That was a great presentation, and gosh, so much work has been done, and this is a great map to leave off on. So we have this as our visual. If you have questions, please put them in the Q&A box, and I will go through them. So Let's see if we get a couple coming in. Well, as we wait for them to come in, Brian, maybe talk to us a bit about how you see, I know you're involved with the Creston Community Forest. How do you see beginning to move this sort of work into some management for Creston?
Well, it's quite interesting because most of the areas adjacent to the valley on the east side, on the Kitchener and going toward Kingsgate side, are now in a community forest license for the Creston Valley Forest Corp. And the Creston Valley Forest Corp has 5 shareholders: the regional district of Central Kootenay, the town of Creston, the Wildsight is a shareholder. The Erickson Community Society that has strong concerns over the Arrow Creek drainage, and the Trails for Creston Valley Society are the owners of the community forest. And the community forest is simply a license, a forest harvesting license. So there's a real challenge in community forest to have it administer that license and do the proper amount of harvest over the long term, and at the same time pay special attention to the values that we've identified. And conversations are ongoing with the forest manager about old growth management within the community forest and how it fits, and things they might do. I think the community forest already provides a better standard of forest harvesting in terms of stand retention, of attention to ecological values, and in terms of planning. And it's managed to do its business in a financially responsible way. None of its shareholders get any of the proceeds of that. The proceeds go into community activities, and the community forest has an objective of promoting local industry and promoting forest or ecological management and activities. So they're involved in forest education and other things. If any questions, I see a couple of questions there now.
Yeah, so the next question is, so it's an interesting project. What was the timeline for this work and the estimated costs?
So that is a very, it took us about a year, to be quite honest. It took us about a year to get it done through the program at Selkirk College, and I have to say that Jan went above and beyond his mandate to do this. He was a mature student with a significant professional background with Parks Canada and that, and he was really into getting a GIS certification and background that he could take forward, and he's now on as an instructor with Selkirk College. But he put a lot of effort into it, finding the models for ecological connectivity and finding the model for electrical conductance. Those were beyond it. Selkirk College provides projects and co-op student opportunities at a very economical cost. I think our total cost for our project was between $10,000 and $15,000, which I don't think could be repeated. But I think a discussion there. They have students that do bachelor's projects, and they have they have students that do projects, and they have bachelor's students that do a thesis type project. So they do some really good work. They've done quite a bit of work, and they've always got interested students that are looking for something that really intrigues them to do it.
Great, okay. And on to the next question. How easy would it be to repeat the analysis if data layers were updated? Say, for example, the detections of blue or red listed species, forest fires, logging. Would you plan to update this periodically? Like how to keep it current?
I think it's important that it can be repeated. It can't be. I don't think it can be repeated that easily, because a lot of it depends on the analysis done by the actual person doing it. The input of new data to it is easy, and in fact, I think it would be important to keep looking for data sets, whether they're big data sets that are updated like BEC or VRI, or similar type data sets, or data sets created by a local group or you know, a different perspective, to put those data sets in and have a look. I'd have to ask Jan just exactly how straightforward the instructions are to repeat the, you know, to make it a standardized analysis, but I don't think it would be that difficult if you have someone that's doing it. And I would encourage folks to think about trying a similar type analysis. You can create your own. Any good GIS trained person, if you have the intellect to suggest what kinds of things would work. One of the issues that came on with Jan and us is that we had this idea. We wanted to see this big picture. We had no idea how to do it. And I have to say, he was patient with us, saying, just do this. Don't ask us to tell you how. And he would question us and ask us what was important and how, if we agreed with how he thought some of these things interacted and that. So it was an iterative process with him. And it came out, the whole concept of the connectivity thing emerged during the project. And so we ran that supplementary analysis at the end to create these suggestion for connectivity zones, and we think they're really valid at giving us the big picture.
Yeah, great. So you had mentioned that you wanted to go back and talk to the Lower Kootenay Band and other Indigenous groups. And so there's a question here of, you know, what your plans are and how you would do that in order to share and create mapping data with them for some of the missing areas.
I have only one answer. It says COVID-19. You know, working with First Nations and particularly Lower Kootenay is often a face-to-face process, and it's just not possible. They're under stricter guidelines than we are. You got to look at what their capacity is and try to work with them. And they've done quite a bit. The Lower Kootenay Band has a number of watershed studies in that. They participated with Kootenay Conservation Program in our Creston Neighborhood Program. The folks there are very interested in working with us and us working with them, and we shared some field trips and stuff with them, but we're limited at the moment by by COVID. We're limited a bit by their capacity and our capacity. And I think it's on our agenda, and I suspect it's on their agenda. They certainly expressed willingness to work with us. And it would be a interesting concept to take this stuff and use it as a background to see what they could add to it, or we can add to their thoughts in the valley. And we've already talked with them informally about where the existing values are, and their role in having a bunch of those values, and our role in respecting what they want to do culturally with their portions of the valley and some of the other portions. And you know, there's a handout from us, and certainly an expression of interest from Norm and Curtis and Heather from Lower Kootenai that we need to get something, and Curtis will tell us that we need to get something that we propose to do and get it to the council and talk to them about it, get their authorization for it. And that's all there in the future, but it'll take time and take some resources.
Yeah.
See some questions here.
Yeah, another question. So you'd mentioned that something needs to be done, including field evaluation and of the maps. And so this person's wondering if you could expand more on plans for that process and what methods you'd use to further the field evaluation and ground truthing of the maps.
Well, I think what we've got in mind here is that we've identified a bunch of natural value hotspots from the existing databases. You know, we know that BEC is pretty well based in terms of a potential. We know that VRI is particularly dated. We know that forest inventory is dated. So when we think about field testing here, we'd like to get together a project that looks at some specific sites and goes out and actually measures the values on those sites. But first we got to figure out just exactly what we want to measure, what is a standard measure, and this is particularly reflective of climate change. What are some of the criteria that would indicate to us what's important in climate change? Interesting enough, the distance to water might be one of those, because Greg's modeling of the climate change in this valley is that it's going to get quite a bit drier in the lower portions, and that's going to be important.
Yep. Another question. So have you discussed with Flynn Rowe how they would accept this data to manage logging in the valley? No, in a simple word. The logging in the valley on the east side is primarily the mandate of the Creston Valley Forest Corporation, and we're in discussions with them, and they put some things in their forest management plan, which gets reviewed with Flynn Rowe. On the west side of the valley, we have it's under the tenure area of Hushcroft logging, mostly, or Hushcroft sawmills, and we just have not got to the discussion with them yet, and we don't have the capacity to zip out and start this, and one of the things I think I know some of those Flynn Rowe folks are
are there, and there's an invite for them to have a discussion with us, or at least to have a look at this. I think you got to have some questions and some things to talk about before you do that. Everybody's pretty busy, and again, you're back into COVID. The only way you can talk is virtually like this. But let me put it this way: it's an invitation. If folks in Flinroll are interested, that they would do that. I'm not aware of any pressing issues from BC timber sales at the moment, but I may be just not aware of it. They do have some mandates out here. We deliberately cut our study area off at the watersheds on the south end of Kootenay Lake, because there are a huge number of issues as you go up the east shore of Kootenay Lake, and we just felt we didn't have the capacity or the mandate to deal with that. There's the Friends of Kootenay Lake and other people that it's more their backyard than ours.
Yeah. Okay. Well, thank you so much, Brian, for an excellent presentation and all the questions you've just been fielding. And I want to thank everyone who's attended and joined us today for today's webinar, and I hope you enjoyed it. Please expect a follow-up email with a link to a recording of this webinar and an online post-webinar survey with just a few questions. And again, that helps us plan for next year. And a reminder, our next webinar is next Thursday, February 25th. And we'll be hearing from Ryan Durand with the Columbia Valley Wetland Mapping Project. And a registration link will be in our follow-up email to you, and I hope to see you then. And for now, thanks again and enjoy the rest of your day.